Hi guys, here we are with our next progression of our little Shamus demo. In the original game, or the original title, you would have these 8-bit characters. So you've got this one character is 8 bytes. So each byte represents the 8 pixels across the row, and then the next row is the next byte within the character. Wanting to make it a bit more friendly than that though, so I've separated them out and set up a little block text file. The idea is going to be that you can define a character that's a character graphic used in the levels. It has a name, and we have our raw bit data here. We're storing it in binary or in ASCII actually to make it more convenient. Now this actually loads, but we don't see anything at the moment. It just phrases the document. It's phrased the elements out. Now, to store levels, if you think about the VIC-20 having 5K of RAM, if you didn't know that, by the way, the screen is about, it's not quite a K, but let's say it's about 800 bytes all up. And if you have 30 levels, then we'll say it's nice round numbers, about 25K or something of just raw text data to store those levels. So it's obviously not going to fit. And even the cartridge version of the game is actually only 8K. So now they could have compressed the levels. Or what I was thinking about doing is, if we have a look at the game, you can notice how sparse the levels are. So I think we store them as a series of spans, block spans, and we just have a little routine that runs through and draws that span in that character. We can make up the whole screen. So we'll get out of this and fire up the VIC-20, which already is running. Here you go. Shamus. And this version is brutally hard, by the way. It's a bit, it's not the easiest game in the world. Let's try it out. So you can see that's me over here, little Shamus. All we need to store for the maps is the color of the row of the line segments. Oh, I ran into the wall. So those horizontal lines, those yellow lines, doing the scrolling. If we just store a bit of data that represents where this block starts and where it ends, and what color and what character it's drawn in, and the display system will worry about protecting those tiles for us. Not doing very well. It's like Berserk, by the way. I guess Robotron and all those kind of old classic arcades. I'm not quite sure what era this was. It was 81, 82 or something. You can see some of the characters there flashing. They're rendering over each other. Now normally in these old games you couldn't move pixel by pixel. This was actually kind of a neat feature of this particular version. Next room. Now so we can, I wish there was a pause there. That's a life counter over there. And he can move into his little hat is actually not part of his body. Ooh, terribly played. So, for storing the maps or making maps, we don't need a tile editor, really. We just need to have a bunch of strip definitions that draw rows of these characters. You can definitely see it slowing down. It did slow down a lot on the original too, so we're not talking about 50 frames per second gameplay on the original, that's for sure. So that question mark, you'll either get a good thing or a bad thing if you pick that up. So it's brutal design. You know, I think it's. I completed this game when I was a kid. There's no way I could do that now. Oof. Judging by how terrible I am at it. Doing so well. Ooh, look out. Some of these rooms are a bit easier to get through. Just got to sit in certain spots and knock them off. I think collisions are interesting too, is that your bullet, if it overlaps multiple enemies, it seems like it will actually kill all of them together. Oh, jeez. Mm-hmm. You've got to point a direction too when you're firing. So if I press the button without any movement, I don't fire. Oh, let's get my extra life. I need it. Generally not good to get close to them because they're such a confined space. I made a 2.5D version of this for a Dark Basic challenge about 10 years ago. No, actually it's longer than that. It was done in a week, and it plays like it was done in a week. Actually, it plays probably about as equally as hard as what that does. But this is the game we're having a look at. We can see all the character types here. We've got our key. You find certain keys, they're different colours. They go with certain locks, they unlock the next section you can get into. And you just move screen to screen throughout the 30 or 31 screens, wherever there is. The Shadow is the end character you've got to battle against. He does come out on during each screen. And the mystery is you kind of get an extra life or the Shadow comes out. We've only got 3 characters: Robo Droid, Spirals, and Snap Jumpers. Yeah, so that's that. So what I was thinking is that for our maps, we could have, you know, like a room definition. Inside the room, you would just have, you know, like a tag like H line, and then this would define a horizontal line. Oh well, it could be something like that actually. Whatever's more convenient, cut and paste friendly. You know, just a pair of bracketed tags, whatever you happen to like, and then, you know, maybe the starting coordinate and the size. You have to have the character as well. So if you have the character name as a H block, so we'd be drawing a horizontal line using the H block character, which it would work out what block that is for you at location 0, 0, you know, 10 characters wide. Yeah, it's probably easier just to have that as one expression, one line, set of parameters, just to make the phrasing a bit easier. You know, so you could have other spans on there. You know, I don't know what the screen dimensions are now, 10, 10 or something. If you wanted a vertical strip, you would need a color too. Actually, that's what you would need. Probably actually use, if you use named colours, it makes it easier to read for the person coming up with the level data or remaking the level data. But that would make the levels be very easy to actually construct. You would need to have, and the system could actually kind of work out what tiles that you need to protect and what tiles you don't. We'll give it a go, see how it works. If it's no good, we'll just put a straight map import in there, character tile map import, sort of character view where it's got maybe a map block or whatever, and then a list of what block indexes appear across this row. Anyway, that's where we're up to. And we'll have a go at doing that this afternoon. Or now, in fact. Okay, just added a maps include to our project. And these will be just a collection of functions that draw that are our character rendering functions. So we've got here map H line, which will draw a horizontal line onto the screen. Doesn't at the moment, doesn't do anything. Did add the find block. Just runs through the block definitions and looks for the matching name. Returns that index at the moment. So we'll use that character index for its for our purposes. So once we've searched for the character by name, we've got its index, and it has to be above 0, so otherwise it's nothing. We might just ignore the color for a second, and what we have to do is we have to grab the pointer to our screen memory. Forgot that already. Okay, so this is our screen pointer. Let's call it pointer, I guess. Now, to compute the position within the screen, we've just got to go pointer. Oh, longhand, I guess. We'll add our Y offset. And this is the number of characters on the row. It's important we use these constants in case we change the number of characters the screen is made up of later. Right. And then we just add on the X at the end. So I'm not clipping this at all, I'm just assuming the location the person's given us is accurate. That'll do us. Now, just run through for loop equals 0 to size -1. We poke a byte here and we'll poke character index at that location. Test compile, see if we made any dumb mistakes. Nope. Right, let's try and do that. Go to our main. So, yeah, we're going to have to change this character allocation here. I'll say from character 10 upwards is available for use in the dynamic sprites. The rest can just be used as objects. So I've cleared the screen, cleared our character map. We want to draw a horizontal line. Color name we don't care about. At location 5, 5, and 10. We do want to know the horizontal line, the block name. Okay, it's H wall is what I've called it. This is the horizontal wall block. Let's never get anything on screen. And we don't. Cool. um, Marvelous. Let's have a look at why we don't. Process objects, player mockup. I think what we'll do first is we'll make sure that we are actually getting a character index. Oh, my laptop keyboard. I don't know how people use laptops all the time. It drives me nuts. Just to make sure we have got an index that makes sense. Just refresh the screen, tell it to wait. I think there's a wait in there too. We don't really need that for the time being. Let's go. We're getting character 0, so that's why we're not getting anything back to render. If we run it in debug mode, now what I'm interested in is what's actually in the character table. Yep, its name actually is HWall, so our search is probably not working. Or our, oh hang on. No, our variable's wrong. Because we've got PB set up to be non-explicit, to be implicit, it doesn't care about. There we go. Well, at least we've found it. Get our screen pointer. So I can remove that little bit of garbage. That's the second typo. So now we have no line on our screen though, do we? No, not very good. Oh. We probably do have a line on the screen, but we haven't actually... What the demo does at the moment is it refreshes the character set. Yeah, it clears the character set every time. I'll pull it up to the start of the frame. What it needs to do, it needs to copy that wall graphic into the character set graphic in memory. And that should probably make it work. Said probably, should have, kind of, maybe, sort of, you know, all those things. So here we've drawn the line across the screen character map. We need to copy the character into the character memory. That's nice. There's a function here that pulls the pointer to that, so it's kind of, we're high leveling it. Peak screen cache character pointer doop. There you go. Well, that's the character set pointer. Go back to here. Now what we need to do is, this points at character 0, so we need to add on our offset of this character. It's going to be character index times 8. That's the first byte of this character. And we need to get a pointer to its actual graphic, which is called pixels. So this is going to be the source pointer. Now this is the character index dot pixels, which is an array in that structure. If we don't give it the index of what we're referencing, it'll actually just return the pointer to the array. So we've got our destination, which is the target and the source, so we can just do a copy to 7. There are going to be 8 bytes in these things always. We want to poke byte character set pointer plus loop peak byte source pointer plus loop. And it kind of works, but not exactly. We get one character on screen. But we can move over him, so that's good. Oh, of course, it's poking all those. We're working out the location of the screen here, but we're never adding the offset to it, so that should be our reason why. There we go. Alright, it's kind of working. If we can add colour to that, we need to poke into the colour map. It's just a little bit different. Just compute this as an offset. Okay, so you've got this plus offset to get to the character map. Then we have color pointer I think it's color map pointer. Just if we compile the chest, yeah. Plus offset. That'll put us in the same location, and we'll poke byte just as a bit of a test until we get our color. Oh, wrong one. It's color pointer plus loop, and we'll poke in. That should make it whatever color 15 is in the foreground. Yeah, there you go. Notice how if the sprite moves through it, it adopts those colours. So the sprites don't have their own colour; they have whatever the screen that tile has. Alrighty, that'll do us. Got something working. Catch you later.